Okay, good day, Grebkov. So today we are covering exponential functions. Okay, now we're going to do the transformation, domain and range, asymptotes, how to sketch, and also how to find the equation of the the function given the coordinates. Okay, but also I just want you guys to remember when you are studying, after maybe watching this video, try to attempt also some questions, and if you have a memo aside, you can also check to see what's actually going on. Okay, so that will help you to understand. So whenever you after listening to this, try to find some questions from question papers that you can use. It actually helps, it actually helps a lot, even if you're studying any subjects. Okay, so just try to do, when you after reading whatever topic it is, okay, just try to go through what you call some questions and see whether you're understanding the topic or not, and also what is required of you to understand in the what you call on that topic. Okay, so that you can focus on what you call important issues in the topic, or important topics that on the subject that you are studying. Okay, so let's get to see here what's going on here. All right. Okay, we'll do this one. Okay, so that's our exponential function. Okay, so it's a to the power bx, and what we have here, what I've just shown you, that it's an original, and what I just want to show you is how to how we sketch this, how the general graph look like. Okay, the mother graph. So what we have there is that if we are saying f of x goes to b to the power x, and we are saying when x is equal to 0, and this in this side, when x is equal to 0, we say any number, b can be any number. Okay, it's representing any number. So if you just say a to the power 0, okay, to the power 0, what do we get? We get 1. Any number, even if we say 1 million, okay, 1 million to the power of, what is it, 0, you still get 1. So that's why we see our our intercept there, what you call our y-intercept is 0, it's 1. Okay, so it's always like that. Now when you start to increase the values of b, like from 1, 2, 3, you find that your values also, it actually increase like that. But now when it comes this side, when it's negative, what is it, negative x, you find that it's actually probably a fraction. Like here, let me give an example. Let's say we are using the same base, like 2 to the power, let's say 2 squared. 2 squared is 4. Okay, but now when I say 2 to the power negative 2, what do I get? I get 0.25. So it actually means that when I have negative here, it's actually going down there, and it's simply because, remember, any number to the power of 0, like any number of the power of 0, is actually 1 over b to the power of 0, like that. So you'll be dividing with a fraction. Okay, so that's why it's going on like that. But now we can't have y as 0. Okay, for example, here, if we say it's y equal to bx, okay, if we have got a 0 here, okay, that one becomes a problem, because we can't have, what is it, we can't have a 0 there, and it will make our the function not called undefined. So here, this one is an asymptote, so y equal to 0 is an asymptote. Okay, you must remember that. Okay, so let's get to see what's happening here. Okay, let's start to see here. We have got a to the power of what you call a to the power of what is it? A is equal, sorry, f of x equals a to the power bx. Okay. Now, always when you're sketching, don't forget to put your origin and the x and y to indicate that. Now, here, when we have generally, what we have here is that if our a is positive, okay, we will have a general function like that. Okay, to increase like that. Okay, so we assume that it's opposite 1. Okay, then if it is negative, if our a is negative, it means that what will we be having here? It means that if our y is negative, for example here, if we are to say a y equal to what is it? If a, maybe a is positive and a is negative, okay, let's see what we have here. Let's just plot to have to what call some point that we can use. So for equation y equal to 2 to the power x, okay, and y is equal to 2 to the power of x, okay, then we say when y equal, when what is it, when what is it, when x is equals to -1, we put -1 there, okay, so we put the x value there, and when x goes to 0 and when x goes to 2, okay, what do we get there? Then let's do the same here, x and y, x and y. Okay, so what we'll be having there is that here you will have here, for here it's 0, it's going to be 0.5. So if it is -1 here, in this case here, it's going to be 0.5 here. Then if it is 0, it's 1 like that. Then if it is 2, it's 4 like that. Now, but when it comes to negative, now when a is negative, okay, in this case we are having a negative. So let's say it's -1 in this case. So we're going to say, all right, if we say, if we put -1 into the equation, it's going to be 1 over 2 times -1, it's going to give us -0.5. Then if to the power, what called, it's going to be y equal to -2 to the power of x. So whatever we get there, we say times negative, it's going to give us -1, and it's going to give us -4. So we end up having a function like that. So if for this one here, a is greater than 0, okay, then for a is less than 0, let me just show you here, you can see. For a is less than 0, your function is actually like this, okay, -1, okay, okay, so that's what we have there. So that's what we have there, okay, that's what we have there. So it's -1 like that, okay, that's what we have there. So in this case here, a is equal to -1, and that's what you must always remember, that it's actually a reflection in that in the what you call in the x-axis. Okay, that's what you must remember always. So whenever you see a negative a, you know that a negative, you know that my graph is actually facing, it's actually under there, it's facing down like that. Okay. Okay, so that's what we have here. That's an example there, okay, to say, all right, in this form here, we are going to, for the transformation, we are saying a b to the power of x plus q. We want to know what the effect of q, and remember from what called previous, what called from hyperbola and parabola, we said effect of PQ is what? It's the up and down, it's the vertical shift. So it's called the vertical shift in the y-axis. That's why that's the effect of Q. Okay. So we just have to move Q units, what called up and down by the given units. Now, so in this case, let's say if our original here is going to be called mother graph is, let's say it's y equals to 2x, and we know that it's going to pass at 2, okay? It's passing at 1, sorry, because that's where 1 is, and we say, put it like that, okay? Now, let's have y is equals to, what is it? Y is equal, g of x is equals to the power of x plus 3. Now, in this case here, we are going to move 3 units. So you're going to move 3 units up because saying plus, okay? So it means that if we're going to move from here, we're going to say it's going to be 2, 3, 4. That's 3 units, okay? So we're going to say 1, 2, 3 there. We end up at 4, and that's what we'll be having now. It's like that. That's our g of x equals to 2 to the power of x plus 3. That's what we have. So always remember that even if you are given it's like this, okay, if it's given, it's drawn like this, you know that, oh, I'm given 4 units, so I must say -1, because already this graph must sit at 1, okay? So it means that its transformation there was +3. Now, for this one, it's saying 2x minus 4, okay? And remember, when you say -4, it's still in the same shape, but now it's saying -4. When it's -4, now it means that we need to move 4 units, -4 units going down. So, okay, so we're going to say, all right, say we count 1, okay, we count 2, we count 3, we count 4. Okay, then now we can see that we moved -4 units, because we need to move 4 units downwards. So it's going to be 1, 2, 3, 4. So this graph here will be sitting here like this. And now, when you move something, when you move it like this, now remember that you need to say, all right, -1 again here is going to be the because you are moving the asymptote y equal to 0. Okay, so if you move y equal to 0 there, it's going to be 5 units in this case because you're going to say +1 here because we are starting from here to move the graph, but for y, you're moving this y-intercept. So remember, when you are here, is now you have got an asymptote here. When it's here now, it's going to be here. When it's here, it's just a 1 unit, a single unit below your graph. That's what you must remember there. So you mustn't forget to draw the asymptote in this case. So asymptote is going to be, what is it? It's going to be, sorry. So it's going to be y equal to -5. That's what -4, sorry. -4, okay? Then in this case here, it's going to be, we forgot to put it. It's going to be, and remember, asymptote is never touched, it's just approached. Now here, what we have here is going to be what? It's going to be, what is it? -3, was just one, so not -3 only, okay? Just a unit below, okay? So that's what you must understand here. When you're moving, when you're the effect of Q, whenever you see Q, you know that, oh, Q is up and down. You must always remember that Q is up and down, okay? So don't forget that. All right, I think we also need to talk about the domain here, domain and range, okay? So when you talk of domain, remember, so let's talk of domain for y equal to 2x, okay? Now, domain for this now, we know that domain is the x-axis. Remember, it's the x values, okay? And as you can see that this graph here can satisfy, what we call x can be anything, okay? From negative infinity to positive infinity. So we say x in this case, x. So generally for graph, what is it? X is element of real numbers. Or what you can say negative infinity to positive infinity. That's your x there. That's your x. So you can put it like that way if you want. Now, if we talk of range, for the same graph here, y is equals to 2 to the power of x. Now, if we check the range here, what is the range? What is the range here in terms of y? Because remember, range is y, and you can see that it will never go down here. The end here, it can only approach 0. So it means that any value, it can occupy any value above 0. So it's gonna be, in this case, y is greater than 0. Y is element of what? Real numbers. That's what you must remember there. So always know that the range is greater than or less than the asymptote that you're given. Okay, it's greater than or less than the asymptote that you're given. So I'm just saying that because in the sense it's like this, okay? In this case here, you know that, oh, what is it? It's gonna be, in this case, range is y less than 0, y element of real numbers. And always domain for exponential, no matter which graph you're dealing with, domain for exponential remain the same. X is element of real numbers. It can occupy any number. It can occupy any value because it's open. It's not restricted in the x-axis, okay? That's what you must remember there. Now, so you know that that's how you write your domain. And if you can check, we just want to give an example here for domain and range for g of x, which is equals to 2 to the power of x plus 3, okay? In this case here, we know that, all right, what is our domain? Range, okay? Now, domain, we know that x is element of real numbers, no matter what, okay? It can occupy any value. But now, in terms of the range, let's check with the range here. Range, what is the asymptote? Asymptote is 3, okay? So we just have to say y greater than 3, y element of real numbers. That's it. That's what you must always remember, okay? So just deal with, what is it? Deal with what you call with, what is it with the asymptote? And in this case here, range okay, it's going to be y greater than, what is the asymptote? -4, y greater than -4, okay, y element of real numbers, okay? So it's still, those values are real numbers, but it's just have to be above -4. That's what you must remember there, okay? All right. So here again, we are adding another variable there, which is p, okay? And p, we are saying x plus p, okay, plus q. Remember what I said, if it is inside like that, what is the effect? It's horizontal shift. So p is actually for horizontal. It's called what? Called horizontal shift. So it's left and right, okay, in the x-axis, sorry. So in the x-axis, that's what we need to remember there. So if p, if our p is greater than 0, okay, if our p is positive, it means that it will move to the move p units to the left, okay? It's always opposites, remember? P is less, if p is less than 0, okay, it move to what called? Move p units to the right. Okay, so if it's negative, it's moved to the right. If it's positive, it's moved to the left. Always remember that, okay? Because we want to cancel here, we want to come up with what original value, the original mother graph. Okay, that's what you want. Now, let's see if we can have a sketch. Okay, that's our mother graph there. Okay, so we are saying this one is y equal to 2 to the power of x. Okay, now we want to draw a graph of y is equal to 2x plus 3, okay? And when we're saying plus 3, where must we go? We must move to the left, okay? So we must move to the left in this case. So what must we do now? We are going to move our graph here. Okay, so we'll take our graph. We are saying we have to move our graph 3 units, okay? So what must we do here? We must move, it means if we move there, our graph, it will touch where? It will touch what called somewhere here. Let's give an example here. If we are to say 2 to the power, if x is equal to 0, okay, if x goes to 0, what is it going to be? It's going to be 2 to the power of 3, which is 8. 2 to the power of 3, which is equal to 8. So it means that our new asymptote, our new, our new value there will be 8, okay? Our new value here will be 8. So what it means here is that, let's say I just put 8 here. Okay, it will touch at 8. And when it touches at 8, what you must master here is that in this case here, you have moved your graph, yes, but the asymptote remains. Asymptote, remains. That's what you must always remember. So you have got here, right? It's touching now at 8, but now that's how you show that you have moved your graph. And now let's see that, what is it? If it is negative, okay, if it is negative now, you find that it's gonna be what called a bit tricky, because if you move this graph here, what called negative units, you are moving to the right, okay? How are you moving to the right now? Okay, because always remember the reason why I'm saying we're moving to the right here, because we want to be left with x here. So if, for example, if it is 2 to the power of x plus 3, okay, we are taking this, what we have here, because we want to be left with the x here. So we're going to say, all right, what must we do to obtain this graph here? That's what we want. What must we do? We must subtract 3. That's why we take what we are saying -3. If it is x minus 3, what must we do now to attain our original? We must add 3. That's how we must. So that's why I say when it's negative, you add. When it's positive, you subtract. Okay, so you mustn't stress about that. Just master the concept. Okay. Now here we're going to say now, all right, if our x is equal to 0, it's going to be what? Because we're just worried because we need to put the intercept here where it's going to touch. Now it's going to be what? 2 to the power of -3, 2 to the power of -3, to the power of -3. Okay, because we'll be having 0 there. Then it becomes what? 0,125. So 0,125 is more like here. Okay, asymptote remains. So that's what we'll be having now. So you can see that your graph here in this case here, it shifted to the left. In this case, it shifted to the right. That's what it means. So it means that here we're going to have our h of x equal to 2 to the power of x minus 3. That's all what we need to remember there. Okay, that's how you must draw, that's how you must sketch your graphs. That's the effect of what called effect of P. So P is just moving in the what, in the x-axis. Then when we start putting something here like +2, we know that, all right, whatever we have in this case here, if you're testing it negative 0.25, must move 2 units up. That's what you must always remember. Okay, so let's see what we can, what's next here, what we can do again here. Okay, so another thing here before we move on to sketching here, I think you face some words like increasing function or decreasing function. Where is it? Is it a decreasing function or is it an increasing function, or where is it increasing? Those are the questions that you can be asked. So like determine which values where your function is increasing or where is decreasing now, like that. So what do you mean by that? So when you're talking of increasing, you're just talking of gradient here. Remember what I said? What you call in algebra to say here, when you're talking of gradient here, in this case here, it's an uphill. Okay, so as long as you can have a gradient that is uphill, okay, you know that, all right, that's an increasing side. Like here, if we have like a quadratic shape like that, it means that in this side is decreasing because the gradient for this side, the line is actually, the gradient is negative here. That's what we expect. And what we call gradient here is actually positive. So we are saying this one will be an increasing side and this one will be a decreasing side. Okay, decreasing in the decreasing side. Then the here is a turning point. The turning point gradient is actually equal to 0. That's what we have. So from 0, we have what you call increasing values from 0, something going on, but they are positive. Gradient is positive. Then in this case here, gradient is negative. So that's what you must always remember when you're talking of increasing and decreasing. Now, so what actually, what cause our function to be decreasing here is when b is a fraction. When b is a fraction, when b is equals to, is between 0 and what call and 1. So remember that whenever you see that it's half or is a third or is something like that, you know that, oh, my b is a fraction, so it means that the shape already is going to be like this. That's what you must always remember. It's going to be decreasing. Okay, so in this case here, it's actually a decreasing. That's what it means. Okay, so that's what you must remember there. Now let's move on to sketching here. When you're asked to sketch what you call a graph, what do you require there? You first of all, you need to see the shape. What is actually the shape of what called shape of the graph in that case? And secondly, you need to find the y-intercept. How do you find the y-intercept? You actually find the y-intercept by looking at what by saying what x is equals to 0. Okay, then x-intercept y is equal to 0. Then asymptote. Asymptote, always remember that asymptote, this is asymptote y is equals to q. So remember that asymptote y is equals to q. Just like when we spoke about the hyperbola, okay, where we said also asymptote is actually like that. So here, that's what you must always remember this. So asymptote is y is equals to q. Simple like that. So in this case, let's say you're given an equation and you see that, oh, that's my value there. It means that whatever is q there is actually your asymptote. And whatever is q there in this case here is actually your asymptote. Then from there, you actually do the domain and range. So let's check here. Let's try to draw this, sketch this equation here. Okay, this equation that we have here, which is y is equal to 7 to the power x plus 1. Okay, by looking at the graph, what is the shape? We know that the shape generally is going to look, it's going to be what? It's going to be, what is it? It's going to be the normal shape that we know. It's going to be the normal shape that we know, because we're looking at b there and we see that the b is positive, okay? And the a, the what you call the coefficient there for b is actually also positive if there is no negative. So you expect to see a general in this shape. That's what we expect to see there. And let's get to see what's going on here. What about the asymptote? So we draw the the graph like that. Okay, let's start to see, sorry, x-intercept, y-intercept. Okay, x is equals to 0. So let's put 0 there. Y is equals to 7 plus 0 plus 1 minus 2. Okay, so it's actually 7 minus 2, where 7 to the power 1 is 7. Then it's going to give us what? 5. Okay, that's what we have here. and let's see x-intercept. So that's what you must do. When you ask to sketch a graph, you find these are the critical components that you must find always. First, to find what is your y-intercept, what is your x-intercept, all those things. Now here, what we have here is going to say when y is equal to 0, it's going to be, what is it, 7, what you call the power x plus 1 is going to be equal to, what is it, minus 2, okay, is equal to 0. So 7 the power x plus 1, okay, is equal to what? Is equal to 2, like that, okay? So here what we do, whenever you face something like this, okay, it's the power like that, okay, you use logarithm. You use logarithm, okay, logarithm. So here there are theorems of logarithms where you say log a to the power of b is equals to b log, what you call b log a. That's what you must remember there. Now, in this case here, and we also have another thing that is the relationship between log. So if we are to say a to the power of b is equals to c, okay, in this case here, it's gonna be log same base, which is a, okay, c, which is gonna be equal to b, okay. So let's have an example there. Example there is what you call example there is what is it? 2 to the power 3 is equal to 8, okay. Then in terms of log, we say log base 2, 8 is also going to give us what called 3. Let's try to see it here. 2 to the power of, what is it? 2 cubed, where's cube? Oh, where are you? Oh, let's just put here. It's 8, okay. Then we say log, where are you log? This log is where now? Now, log, okay. So we have log there, base 2. Now what we have here, 8, okay, we get 3, as you can see that. So that's what I'm talking about here. So always remember this rule in case you face something like that, okay? Now, so we are going to apply log here. We apply log both sides. It's going to be log 7x plus 1, okay, is equals to log 2. Then remember the law that we just said now, which when log a is log 8 to the power b, we take b that side, okay? So if it's not clear there, we are saying log a to the power of b is equal to b log a, or log 2 to the power of 3 is equals to 3 log 2. That's what we are talking about here. So we're going to say it's going to be x plus 1, okay, log 7 is equals to log 2. Then you divide both sides. You divide both sides by log 2. So x plus 1 is going to be equals to log 2 divided by log 7, okay? Now I'm going to say log 2 okay, divided by log 7. What do we get? We get 0, something like that, okay? Then we say what is going to be our x there? X is going to be equal to log 2 over log 7 minus 1. What are we going to get there? So if we say this one here, minus 1, we get negative 0.637 or 38, okay? That's what you get there. Okay, so we have our values here, y, we've got x, but now what's left now is what? It's an asymptote. Asymptote is going to be what? Asymptote. We know that is y equal to q, so y is going to be equal to, what is our q there? our Q is -2, so that's our asymptote. Then now let's draw the graph now and see what we are going to do there. And remember here we're going to say it's minus, it's +1, so it's going to move to the left by one unit to the left. Okay, remember that. Now let's draw here and see what we're going to have. Okay, thinking this idea. Now, what are we having here? We are saying, okay, it's it's y, then it's what, it's x and it's 0. Now, our original graph must be, which is 7 to the power of x. 7 to the power of x, we believe that it must touch at 1. Okay, but that's not the one that we want. Sorry. We believe that it must touch at 1. Okay, it must touch at 1 here. It must pass at 1. Now, we are told that because the equation here is y equal to 7x plus 1 minus 2. Now, we are told that we need to move -2 units in the vertical axis. So we're going to move -1, -2. So it means that we are at -1. Okay. So that's our graph here. So our second, we have transformed our graph here to this now. So that's what we have now. Okay. Now we are told that no, we haven't started yet. We need to move this again, this graph here. How many units? -1 unit to the left. 1 unit to the left because it's +1 here. We need to move it horizontally. Okay. So we're going to say, all right, now our graph, what is it going to be here? Is going to come this side now. We need to take it this side now. So by taking it, by moving this side, it means that it's actually changing the y-intercept there. So that's why we have y as 5 here. That's why we have put our y as what we call as 5. So what we're going to do here, we're going to say, all right, a 5, we'll put our 5 there. Okay. Then our asymptote, we said our asymptote is what? Asymptote is -2. So when at -2, we mustn't forget that. -2. So this was supposed to be the first thing to draw, the asymptote. Which is equals -2, y is equals -2. So what we have now is that when it's past set, y is equals to 5 and x is equals to -0.5. So here, when you say -0.6, it's somewhere here. So you can just kind of say put -0.64 like that. Okay. Now, so our equation, our graph now has to pass through the x-intercepts. So what's important? Let me want to show you here. Okay. Okay. Now, what's important here, where you're going to get your marks is your y equal to -2, your asymptote. Okay. After asymptote, we need the x-intercept. Okay, you get your mark there, and we need also the what you call the y-intercept. You understand? That's what's very important. So you can see that how we have moved our graph. We started by moving -2 units, and we move -1 what called by 1 unit to the left because it's +1 here. When it's plus, we move to the left. When it's positive, we move to the right. Okay, so that's what you must have here. Okay. Okay. Now let's talk of the domain. Oh, domain, we don't need to worry because we know that x is element of real numbers, can take any value. Okay. Now what about the range? Okay, range, we know that it's supposed to be the minimum value here is -2, so it's y greater than -2, and our y is element of real number. So it's very easy here to deal with what called domain and range here. Okay, so you know that you have done your sketching and you get all your marks by having all these things that we're having here. Okay, so let's see which next. Now let's try to sketch this one again. Okay, but I'm not going to finish this one with you. There's just something that I need to indicate to you here. Okay, so when I'm saying sketch a graph of this form, First of all, yes, we said right, you must find the y-x intercept and x-intercept, but first make sure is in the form of y equal to a b x plus q, sorry, plus p plus q. Why are we saying that? We are saying coefficient of y must be 1. So always must check that coefficient of x here is of y is 1. So in this case here is not 1. So what must you do first? So before you do anything, your first thing to do is to divide by 2 throughout. So it's going to be 2y equal to 10 times 2x plus 1 minus 5. Now what do we have here? We're going to say, what is we divide by? We divide by 2 there. We divide by 2, so it's going to be y is going to be equal to 5, because if you divide by 2, it's going to be 5, okay, times 2 to the power x plus 1, okay, minus what? Minus 5 over 2, minus 5 over 2. That's what we have there. So in this case here, asymptote is going to be, you know that it's going to be y is equals to negative 5 over 2. Okay, because it's no longer y is equals to negative 5. So it's something that you need to master there, so that you don't take negative 5 here, not thinking of what called y there. So you must check y and first make sure that it's y. What coefficient of y is 1. Then after that you can actually play around with it with your question. Okay, so in this case here, so I've shown you that the asymptote now becomes negative 2, and now from there you substitute for x, which is going to be equal to 0. Then you find the value of y. From there, you find the value of x. Then what is it? You find the, what is it? Let me just give you the values. Okay. So let's say you're dealing with, what is it you're dealing, we are given this type of question. Okay. So you know that, all right, determine the equation of f that pass through 2, 2, and what is it, and 3, 4. Now, you know that what I'm going to do now, you know the equation, general equation, 8 to the power of bx, that's what you must come up with, okay? Then from there, you substitute your coordinates. So you're going to say for 2 and 2, what do we have there? It's going to be 2 is going to be 2 is equals to ab squared. Then that's your equation 1. So you're solving simultaneously now. Then you're going to say for 3 and 4, what is it that we are having? You're going to say it's going to be 4 is equals to ab cubed. That's equation 2. So now you're solving them simultaneously. Equation 1, equation 2. So you can say now in equation 1, okay, a is equals to 2 over b squared. Now that's what we have there, because you're going to make a substitute the formula. So you substitute a in 2. So you're going to say it's going to be 4 is going to be equal to 2 over b squared times what called times b to the power of 3. Then now once we have this b over 3 divided by 2, okay, b over 3 over divided b over b to the power 2, you know that a to the power of b, okay, divided by a to the power of c is going to be equals to a to the power of b minus c. This is the rule of what called law of logarithm. So it's going to be equal to 4 is going to be equal to 2 b to the power 3 minus 2, which is going to be 1 there. 3 minus 2 is 1, so it's going to be just b. So in this case here, b is going to be equals to 4 or divided by 2, which is equals to 2. So you find the value of what called the value of b, okay, to find that it's actual, it's 2. Then you substitute your what you call your b equal to 2 in 1. In equation 1, we're going to say, all right, it's going to be equal to 2 is equals to a, what is it? So here to find a, okay, a, b, what is b is 2 squared. So 2 squared is 4. So a is going to be equal to, what is it? 2 divided by 4, which is going to be equal to what? Half. Gonna be 1 over 2. Okay. Now the equation now becomes a substituting equation. Your b equal to 2 and your half. Your equation is gonna be y is equals to, what is your a? 1 over 2. What is your b? Is 2. What is your x? Is just x, like that. That becomes what you call your equation, like that. Okay, so that's what you must do when you want to find what you call the determining the equation of what you call of exponential. Okay. Okay, guys, so this is the end of the lesson. Okay, this is the end of the lesson. Okay, I hope you guys, you enjoyed your enjoyed your lesson. I wish you guys the best. Okay, so until next time, cheers.